Right, so now we're going to look at feature engineering and data cleaning. And the data set that we're going to use is the Titanic. So this is basically from the ticket data on the Titanic, can we predict who would survive and who wouldn't? So we're going to pretend we've already just done the exploratory data analysis. We're going to make sure that we've got our target selected, because this is basically the basis. If we want to have any of the column scores come through, we need to have our target selected. And then if we've done our exploratory data analysis, we're going to see that passenger ID is not a very useful variable. So if we want to remove a column, want to remove passenger ID, we can just come in here and we can click remove original column, and that's going to remove the column. We can see now it's saying unused, and that's basically going to remove it from our data set. And then the next thing we might want to do is we want to change a data type. So, we can see that class is numeric, but there's only 3 values like first, second, third. So is that actually really a numeric separation, or is it that there's, are they sort of different things entirely? So would it be better represented as a categorical variable? So here we can see that the valid column types on line 6, and we want to change this from a numeric to a categorical. So we're basically going to copy the categorical, put that in here, and now it's going to run and do the scoring for us, and we find that it makes absolutely no difference. So really not any more information from treating it as a categorical or for numeric. So we can set that back. But if we wanted to do it for different columns, now we know how to do it. Right, so then the next thing we might want to do is we might want to use some of the examples. So we saw we got that code window there, but it's basically like if we use code examples, how can we do that to do some more data cleaning and feature engineering, some more complex stuff? So if we look at cabin, we can see here that we've got 77% of the values are missing. So this is a case where there's more missing values than there are actual values. And then when we look at the actual values, we can see their individual cabin numbers. Now, there may be some slight difference in the value of different cabins and people being in certain regions and things like that. But overall, there might be a lot of information just if you had a cabin or not. That might be just one of the biggest dividers. So if we wanted to have a feature that told us, do they have a cabin or not, we can open up the column code examples. And when we go in here, we've got a bit of general help. And so what this is going to do is it sort of explains things like, what this function signature means, how to work with that, because that's a bit new. And it also covers off things like the outputs and how we do the scoring. So you can always catch up on this. But then we've got different clean transform steps, which are a bit generic, and then specific ones for the different sort of column types. So here we're going to look at a pretty generic cleaning step, and we're going to say is null. So so we want to apply this code to say, is this column going to be null? So we click apply, and then we can see that this has generated a new column, cabin is null. And that's because it's basically using column name plus underscore is null to produce that output. And we can see that that's again column name is null, and then it's basically done the map lambda pd isna, and so that's going to tell us whether it's null or not. So we can basically see from this instantaneous feedback that actually that seems to be a pretty good improvement. We can look at the distribution of values. It's a categorical. We can actually look at the raw data as well, so we can see like, what does the raw output look like? And in this case where it's true false, it's less interesting. But if we were doing some string manipulation or things like that, it can be quite often to be able to just see those outputs as well. So let's just look at another example. So that was one where we just kind of use one where we don't have to do any editing at all. But if we look at fair, so looking at fair, we can see, there's actually quite a range of values, and actually like the max value is quite an outlier. So potentially something around 150 or 100 might be a good range to clamp things to. So if we want to go here, we can look at the numeric columns, because this is a numeric column. We can see that clamp range is actually the first example that we have. So we can click apply here, and then we can basically look. So obviously this is basically giving us a 1.2% increase. If we want to try out a different value, we could say, would 150 be better? And then we see that it wouldn't. So we go back to that default. But you can see that you can actually, change the values up. You can try, you can play around, you can look at what would work and be the best for your data. Okay, so that's covering off the examples and how to use those. And now we're going to look at, just a bit of an explanation on the column scoring. So basically what we're doing here is we're running a linear model, deep neural network, and XGBoost. and we basically choose the best score on the original feature and the new feature, and we basically compare what those scores are. So basically this just means that it's basically not limited to a specific model type so much. So if there's one that performs better, as we often see for different problems, you're going to get a reasonable max. And it's kind of like a univariate analysis in this case, where, in this case it will be a univariate analysis because it'll be this variable versus that variable. But in the cases where you're either inputting multiple variables or you're outputting multiple variables, it'll be sort of, the inputs versus the outputs. And this is great because as you see these improvements, they're what you're sort of seeing on this feature level, but you do have to be mindful that, once you get up to the AutoML and using those bigger, more powerful, complex models, they might actually intrinsically learn some of these features. So you should still see some benefit, but you might not see like all the benefit. You can't just basically sort of say, oh, I got 1.2% here, I got 10% of the other feature, I got da-da-da-da, my new model is going to be X% better, but it should be an improvement. And actually, even by doing this, you're actually making the data representation to the machine learning easier. So even if the score doesn't improve so much, you're actually allowing a less complex model to get the same results. So basically let's start looking at more custom coding of features. So basically if we take in age now, so now we're going to go through this signature syntax in a bit more detail. So we've got this input column. So the input column here, basically this specifies which columns are going to be given to this function that we're about to use. So we can create a list here. So we could use as many different columns, and we can use column name. And the reason why we have column name as this sort of default variable is so that you can copy and paste things between different windows, but you could just as easily, use a string. So I could replace this with age, and that will just be exactly the same as basically using column name. It just means that I wouldn't be able to copy and paste this code as easily to run somewhere else. And if I wanted to use age and fair, I could just as easily just type in fair. And now I've got two different columns that are part of the inputs to my transform function and are also available in the fit function. So just so you know, basically, obviously, if you want to use a fit function, you have to do this to actually do things. We're going to maybe, look at get maybe a denominator for normalization across your whole data set. Or if you're going to do target encoding, you need to look at your targets at a point where you actually have access to those targets, which would be, on your training data. Then you can save these values off. You can then basically pass a dictionary or any single value or whatever you want. We just doesn't support complex types. And then you can send this here, and then these values will be passed exactly into the fit data of your transform data. So this means that when you're looking at your transform, you will you'll be able to basically take that data. So even at predict time, you'll have that same data that was got at train time. So this just allows you to apply those sort of more aggregate stats even at predict time. So we've talked about how we can input multiple variables into this signature. The same for outputs, but basically for output columns, this is already a list. So basically we have a list here, and we basically have column name and numerics. That basically says, replace the current column with the new column of the same name. But if we basically give this a slight change, so we basically said, different. Now basically this is going to output an entirely new column. And we need to make sure that the return signature matches the output signature here. And if we wanted to add multiple columns, we can turn this from a single column into a list. Now each column needs to have the identifier of the name plus the type. So we're just going to basically add another column. And if we made this column, let's say different 2, then we would basically need to add another new output column called different 2. So these changes here haven't done anything particularly useful. In fact, we've just added more noise to the data, so the results are slightly worse. But you can see in this way that you can add multiple variables in, you can have multiple variables coming out, you can have any combination that you want. So hopefully that helps you understand the signature a little bit better. And now if we're going to actually look at age and how we might actually transform age to do a bit of actual custom coding, now that we've kind of got the signatures and stuff out of the way, We can see here that like there's this distribution. We've got a lot of very young people, well, a bunch of very young people, less people in and around the age of 10, and then this sort of cluster of people in the 20s to 30s, and then it sort of trails off as we get older. So if we look at this versus target, it can be, we can sort of see that actually, yes, there's more people survive of the younger category, and then as you get a bit older, it sort of changes, and then basically more people don't survive than survive as you kind of get older. So this sort of goes along with that sort of women and children first thing that we know from the Titanic. And if we look at this proportionately, this is just the same thing, but instead of seeing the height of the bars to understand the quantities of values, we're just looking at the proportional differences between survived and did not survive. And we can see that sort of, around 8 looks like an interesting boundary, and then sort of maybe around 4 as well. So if we're to look at this, we could basically say, okay, so I want to have a new column output, and this is going to be less than 8, right? So now I'm going to go here, and we could have just done this with quantiles. So we could have basically said, oh look, I'm going to just do numeric, get quantiles. I could select about 10 quantiles, and I'll get an uplift from that. But basically in this case we might say, well, I'm going to do something just a little bit more custom because I want to get a better result. So here we're going to do the dot map, then we can do lambda x, and this basically just means per row, we're now going to do this transform, and we say x less than 8. And yeah, this is now a Boolean, so we need to change this to a categorical because it's not a numeric anymore. Cool. So now we've managed to get, almost an 11% uptick from that. And we might think, hey, that worked really well. Maybe if we add, less than 4 or less than 5, is that going to be a good column to add? So we can basically start, as we say, creating this list. We then basically just can drop that down. And now basically say, okay, less than 4. Okay, and now we're going to say column 2, less than 4. And then we're going to say this, we're going to output another column here, and this is the less than 4 and column 2. Dun, dun, dun. So that's still an improvement, but actually we've actually slightly hurt the score. So basically often what we'll find is when we add variables that aren't that predictive, it's slightly more noise to the model, and it means that the models are going to perform worse. So actually we're better off just having less than 8. But we're just going to go back and look at what would happen if we just used the sort of, instead of doing the custom feature, we just did quantiles. Oh, and just basically, if we want to actually look at the values of each of these variables, we can see here, here's the true false, here's the proportional. So we can see that actually, we are actually capturing quite a nice, difference here with the less than 8s. And potentially if we look at the less than 4s, it still looks like quite a nice difference, but maybe it's just not as marked. So maybe it doesn't give us any more information than we really had from the less than 8s. So if we go in here to the quantiles, we can basically do apply code, and then we can say, right, we're going to use about 10 buckets. That seems like we better. So that other one was about a 2% uplift, and then this one gives us about a 4% uplift. So, using the examples, you can definitely get to good places. Often with a bit of customization, you can really, eke out that extra value. Great. So now basically for the next feature, we're going to look at how we can basically combine multiple inputs. So here we basically got the number of siblings and spouse. So the number of siblings and spouses, so basically how many, brothers and sisters, and do you have a partner? I mean, I don't know, maybe there's some people with polygamy, so it might be multiple partners, unsure exactly. And then basically you've got the number of parents and children. So basically I have no idea why they decided to join the variables like this, but they did. So, but we might say, right, well, give the combination of these variables gives us the family size. So here we can see some things where we kind of have, well, you can see here where you've got values on this side, no values on this side. I'm sure you can get to the point where you've got some times where you're going to, yeah, here you've got like one of the values here, no values here. So basically, is there interesting data just basically from the size of the family, or for if there is family on board? So if you want to create a new feature like that sort of family size, so we're going to go in here and we're going to say, right, I'm going to create a new feature, family size. And it's worth saying that basically, unless you actually tick the remove original column, you're going to keep your original column as well. But if you wanted to basically add a new column and remove the original columns, then you'd want to basically tick remove original column. So I'll show you that in a minute. So here we want to keep SIBSPA, but we also want to add parents and children as a new input. Right. So that's basically just this currently the same as the column we originally have. And now we're going to add in, and we basically need to change this. So we're now going to add the two columns together. So this one is SIBSPA, this one is parents and children. And we can see that that gives us almost a 5% increase. Now I might say, oh, does this replace the value that SIBSPA was providing? So if we wanted to remove SIBSPA, we can try that out. And we can see that no, actually SIBSPA is also giving us a different set of information. So we definitely want to keep that column. So that's showing us how we can combine some variables. So hopefully this has given you a good idea about how you can do feature engineering and data cleaning with the platform. And then usually, once you've now, done all these changes, we can dive in. We can look at our exploration. We can see these features. And then basically, we can see them, how they're sort of, stacking up against each other, which can be quite useful. So, cabin is null is now like one of the top features. We can see that sort of family size is actually outperforming parents and children. So, Ferris is much improved over what it is. So you can see that, okay, that's great. And then basically, once you've kind of done your analysis, decided what you want to do, then you can basically just get on and create your models.